Howdy, AP PreCal. It's Miss Kosh. I am coming back for the second of possibly 3 videos to talk through the end of the Unit 2 review sheet. Oh my goodness. Okay, I am going to make some assumptions that you watched the first video because I'm not going to go through all those calculator details, but I've got the next set of data into my calculator already, and I can come over here and I can graph those points, and I already have it set up where graph 1 graphs those points just as they are. I'm going to once again do a linear, a exponential, and a logarithmic graph for this one. So I'm going to calculate the linear regression, and I'm going to copy this. Actually, you know what? I may write this down. That appears that it, okay, well, let's see. Y is equal to 34.6 plus, x, there's the x. See, because I forgot, so I had to look down here. Plus 18.7333. Okay, I'm going to copy that into Y1. I'll draw it just to see. And then what I'm really concerned about is exiting back out and coming to look. Notice the residuals populated, to look at the graph where the residuals are, and that looks random. So I'm hoping that this linear one works. But let's exit back out, go back to graph 1. We're going to calculate the exponential regression, and then, okay, there's that. You can kind of tell that the graph doesn't really fit, the data doesn't really fit that graph, but now we'll exit back out. When I look here, I have new residuals, and so graph 2 will let me plot those, and they seem to have a pattern. There was the bell. Okay, so they have a pattern, so that tells me that the exponential is not a good idea. I'm going to exit back out, go graph the first one again. If you watched my first video, you'll notice I messed up, but I have learned from my mistakes. I'm going to calculate the logarithmic equation. I can draw that one, and as I expected, it didn't look so great. So let's look at exit. Here we have new residuals again. We're going to go to graph 2, and that one also appears to have a pattern. Okay, so what I think we need to use, this set of data is showing us that it's linear. So we can come back. We copied it from the very beginning into, where am I here? We copied it, I wanted to go here. We copied it into y equals, there's our linear equation. I can select this, go draw that line. Oh, I forgot. The last thing I want to do, menu, statistics. If I have it graph this one, it'll create the world that I want, like it'll set the window for me. And so then when I come back to graph, and that is selected, okay, good. I can draw, now I have the window that I want. And the question was predict f of 10, this is f of x, whatever, I didn't write that. And then figure out f of what equals 150. So we have those 2 tasks. GSolve, come over to xcal. I went backwards. 150 is the y value that we want, and so the x value that corresponds to that is about 3.7938. The other one, GSolve, come over to ycal. We had an x value of 10. Oh, we forgot. We had to change our window. Exit out. Change our window. We need to be bigger than 6, so 11. I lied. We need to be bigger than 10. Draw. Now I can do GSolve and come over to ycal, plug in 10, and I get that this is about equal to 364.7333. Fantastic. I could have come over to table and put in and turned this on and come over here and typed in 10 to find that value that way. That might be easier. It's not going to let me go from the other direction like that one did, but whatever. You know what? Let's keep going. Here comes the next set of data, so you get to watch me do everything I would do. I'm going to come back, menu, statistics. Let's clear out, delete all. We'll just delete all, this one, but my x values stayed the same. So now I'm going to type in my y values. Hopefully I got them correct. Okay, so now I can come over and graph. And there, this one. So the idea was it was a linear, an exponential, and a logarithmic. What's your guess? We've seen the linear and the exponential. Ooh, maybe it's a logarithmic. You're very smart. Okay, so I can look at the linear one real fast. When I draw this, you can see it doesn't quite match. When I exit out and go to graph 2 with the residuals, it does appear to have a pattern. So that wouldn't be our best choice. I can then graph 1 again. I can calculate, let's look at the exponential one. Notice I don't expect it to be exponential, which is why I'm not copying it and that kind of stuff. I can draw it. That definitely doesn't appear to match our data. I can exit back out, come to graph 2, and once again, this looks like it has a pattern. So now, third time's a charm, graph 1 again. We're going to calculate the logarithmic equation. We're going to copy this one. We'll copy it right there, and we're going to have it draw, and that sure does seem to fit the data better. Okay, let's go look at the residuals. So we exit out, we go look at graph 2, and they definitely appear random. So that is a good sign. I am learning as I do this multiple times that I want to go back to graph 1. So now my calculator has changed my window back to a reasonable domain and range for the data. So now when I come menu, graph, turn this equation on, I can draw this. It's now in the window that I want it to be in. Except now I've also learned that 10 doesn't usually show up in my x values, and that's the thing that they're asking us to do. By they, I mean me. I wrote this problem. Okay, so I'm going to change the window to 11, so it's bigger than 10. I'm going to draw that again. I'm going to do G-solve. Oh, I didn't write down my equation. Well, you're fine. You can write it down. Do YCal. I wanted to know what it was at 10, and at 10 we have this value right here, 96.19695, which becomes 1570 is how those 4 decimal places would work out. And then I can also do G-solve and come over to XCal, and I wanted a Y value of 150. Oh, ha. It's going to be really, really, really ridiculous out there. So if you think about this, that was not, where am I going? Menu. If you look at the table, turn this on and look at the table, these values grow. Actually, hang on, exit, set. Let's go to 25. Okay, these values grow quickly at first, and then they don't go quickly. They don't grow quickly at all. So here, I might get to 150, but I need a much bigger window to go find it. So we can come back to the graph. I can change my window. Instead of just 11, let's go, I don't know, 300. We'll see what happens for us. And there's another bell. Okay. G-solve, I wanted to know the x value when y equals 150. And it found it for us. So it's about 67. So 300 was a little ridiculous, but there we go. So just kind of adjusting our window helped us find that. All right. I hope that was helpful. Now go practice. Good luck.